Welcome to Virtual Wisdom Finance and Accounting Tutorials. My name is Peter and I'll be your host in this particular tutorial. Today, I want us to look at simulation. Simulation is a topic in quantitative methods or quantitative techniques. And in simulation, we are going to start by defining what simulation is. Simulation is a technique that imitates the operation as it evolves over time. It is basically a technique of conducting experiments on a model of a system. What we mean by this is, instead of you carrying out an experiment using the actual system, you use a prototype or a sample of that system instead. With that particular nature of activity, that is what we are calling simulation. You are simulating the main system using a prototype. Simulation can be applied in various ways. So we have several general methods which can be used to solve problems in many areas of management. So such areas where simulation may be applied include 1. Inventory management, 2. Queuing problems, 3. Capital budgeting, 4. Project management, and 5. Profit planning, or what we call cost volume profit analysis. There are various types of simulation models, and these types include the following. 1. We have the static simulation model, which is a representation of a system at a particular point in time. Then there is the dynamic simulation model. We also have the deterministic simulation model, stochastic simulation model, discrete simulation model, and lastly we have the continuous simulation model. I have explained what these models are. You can look at these short notes and maybe it's going to help you get a better understanding of what these types of simulation models are. Having looked at that, in this particular tutorial specifically, I'm going to look at Monte Carlo simulation. And Monte Carlo simulation is a simulation that specifically deals with allocation of random numbers. We are going to see how Monte Carlo applies application of random numbers in simulation. So what we mean by that, Monte Carlo sampling or simulation can be applied in systems that contain elements that exhibit chances in their behavior. That is, you're not sure that the future is uncertain. It is something that you cannot predict because the behavior is so different. It keeps on changing. There are variations in the various variables in that particular case. So when we have variations in the variables, that is where you bring in the concept of Monte Carlo simulation. By a system here we mean a collection of entities that act and interact towards the accomplishment of some logical end. So simulation can be used in various scenarios, and some of these scenarios are explained below here. So when can simulation be used? 1. Simulation can be used where the assumptions made are unrealistic or unattainable. If, for example, you are developing a system based on assumptions, and the assumptions that you're basing the system on are actually unattainable or they are unrealistic, then you can apply Monte Carlo simulation. Number 2, when the system takes too long to observe. For example, if you want to observe a population of people in the next 100 years, it is obvious that you might not live to see 100 years to be able to observe the demographic changes. And therefore, for you to study that population in as long as you live, you may need to come up with a simple system or a representation of the real population. That is a prototype for the entire population so that you can study it within a shorter period of time. The other thing is when the cost and danger of experimenting with the real world situation is very high. If, for example, you want to carry out a study in a planet that does not support life, you may not go there when you know for sure the planet does not support life. But you can have a prototype of a human being going to that place and being able to carry out the research. So basically that's what you're trying to simulate, or you can create a similar environment here that you can be able to study instead of you going to the main or to the major environment. That is what we mean by simulation. 4, where there are difficulties in making observations. For example, if you're studying molecules of water in the ocean, you may not be able to study each and every molecule in that particular ocean, but instead you can have a portion that will represent the entire ocean, and that portion that you're picking is a prototype. You're picking a small space that can represent the entire population. So basically these are some of the reasons or the areas and reasons why simulation may be of importance, or where simulation can actually be applied. There are various steps when it comes to Monte Carlo simulation. Step number 1, set up probability distribution for the relevant random numbers. So the first thing, you need to calculate the probabilities. We are going to see that in an illustration. And then step number 2, build up cumulative probability distribution for each of the variables set up. So after getting the probability, calculate the cumulative probability. We are also going to look at that. Then step number 3, establish the intervals of the random numbers for each variable and allocate the random number ranges. I'm going to show you how to allocate random number ranges. That is, after you have gotten the random numbers, you have the probabilities. Now you're able to allocate the ranges. Then apart from after allocating the ranges, you need to obtain the random numbers that you are going to use in the whole process. These random numbers can be obtained in various ways. You can get them from using random number tables. You can get them using the calculators, or you can use the computers. Later on in my other tutorial, I'm going to show you how to generate random numbers using the various devices. Lastly, after obtaining the random numbers, you now go ahead and run the simulation trials. We're going to see that better in an illustration. We go straight to an illustration that is going to help us understand the whole concept of simulation. So this illustration is saying that Peter Olo is a fishmonger in Kisumu. As a result of adverse business changes in the region, the supply and demand for fish are subject to random variations, making it difficult to project the next day's business. Then management accounts in relation to the previous 300 days reveal the following mode of behavior. So you're given the number of fish purchased from the fishermen, number of days, the number of fish sold to customers, and the number of days. The question continues by saying that Peter Orlo buys each fish at 40 shillings and sells it for 60 shillings if sold on the same day. If the fish is sold the following day, it will fetch only 20 shillings. If not sold during the second day, its value drops to 0 and Peter Orlo donates it to children's home. Peter Orlo's policy is to satisfy the day's demand from the fresh fish first, and any further demand will be satisfied from the stock of fish from previous day. Failure to satisfy demand costs Peter Orlo shillings 20 for every fish not supplied to the customer. There are no back orders in the business. Then you're required simulate Peter Orlo's operations for 8 days, clearly indicating the profits made each day. 2. What are the average daily profits for Peter Orlo? Then you're given, use the following random number. So you're given the random numbers there. Let's try to understand the question. Anytime that you're given a question to solve, the first thing is to understand the question. Once you understand the question, it will be very easy for you to handle the question. So the question is saying that Peter Orlo is a fishmonger in Kisumu. As a result of adverse business changes, so already we have seen that there is some kind of behavior in the business. There are some changes. Then the supply and demand for fish are subject to random variations. Very important point, that the supply and demand are subject to random variations. So that means the supply and the demand is not is not predictable, because there are some business changes. They don't know what they are going to sell. They don't know how much they are going to get supplied with at a given time. So already we have seen that there is a variation. So what does that tell you? It simply tells us that this question qualifies for a Monte Carlo simulation, because we have said Monte Carlo simulation is applied in situations where variables are changing and there is some kind of behavior in the variables, and we have already identified that the supply and demand are actually behaving in a certain manner. They are random. There are some random variations, making it difficult to project the next day's business. So it is not possible, it's not easy for this businessman Peter Law to be able to predict the next day's business. Then you are given management accounts in relation to the previous 300 days reveal the following mode of behavior. So this is historical data for the previous 300 days. So given the number of fish purchased from the fishermen, so what does this represent? This one is going to represent what? The supply, because this is what you're getting from the fishermen. Then number of fish sold to customers. So this is going to represent what? The demand. So as you look at that, we are given out of 300 days. So it's saying out of 300 days, in 30 days the supply was 100. In 60 days the supply was 200 etc. The same way, in 45 out of 300 days the demand was 100. 60 days out of the 300 the demand was 200. So you're able to get the probability of making a sale, that is on the demand, and the probability of getting a supply, that is receiving, based on what? The number of days that you have been given there. We continue. Peter Olo buys each fish at 40 shillings. So 40 shillings here is the buying price, that is the buying price per fish. And if that fish is sold the same day, it is going to fetch 60 shillings in the market. So this is the selling price if the fish is sold fresh. Then if it is sold the next day, it will only fetch 20 shillings. So the selling price for the next day, that is fish belonging to previous day, fish that were not sold but are sold the next day, they are going to fetch 20 shillings. What does that tell you? That Peter Olo is going to lose 20 shillings for every fish that was not sold the previous day, right? Because it was bought at 40 but to be sold at 20 shillings. Then we are told if there are fish that remained and they are not sold for the second day, the value will drop to 0. This means that he's going to make a total loss because that fish cannot be sold in the market. And what will happen? It will be donated to children's home. Then his policy is to satisfy the day's demand from the fresh fish first. So if Peter Law is having 10 fish that remained yesterday and they have 20 fish that were bought today, that is fresh, they have to sell the 20 first and then sell the 10 belonging to the previous day. That is the policy for Peter Law. Then failure to satisfy demand will cost him 20 shillings for every fish that is not supplied. This is a penalty for not satisfying the demand. This is like saying if the demand exceeds the supply at one given point, it is going to cost him 20 shillings per fish for not meeting the demand required. Then there are no back orders in that business. Then you're supposed to simulate Peter Olo's operations for 8 days, clearly indicating the profits made each day. Then after that, we get the average profits for Peter Olo. Let's get straight to the solution for this question. We start with the first part of the question. Simulate Peter law operation for 8 days, clearly indicating the profits made each day. So we are going to follow some steps. One, you are going to calculate the probabilities, get the cumulative probabilities, and from that we are able to assign random number ranges. Then the random number ranges will help us to allocate the random numbers, and then after that we can be able to simulate the profits for 8 days. So this is how you're going to get the probabilities. Let's start with the supply. The supply here represents the number of fish that were purchased from the fishermen. So we are told in 30 out of 300 days, the supply was 100. So what does that tell you? That the probability of getting a supply in these particular days will be 30 out of what? 300. That's why I'm saying the probability will be given by x, which is the number of days, divided by 300, which is the total number of days. So 30 divided by 300, that is 0.1. Then 60 divided by the 300, that will be 0.2, all the way to the last item there. Then to get the cumulative probabilities, you have to add. So cumulative, you are accumulating the probability, so you are adding up the probability. So we start probability for the first day. Then for the second, for the first category, for the second one, you're going to add 0.2. So 0.1 plus 0.2 will give you 0.3. Add 0.3, it give you 0.6. Add 0.3 to give you 0.9. Add 0.1 to give you 1.0. And these represent what? The cumulative probabilities. Cumulative probabilities. The next thing is random number ranges. Random number ranges. To get the random number ranges, this is what I normally do. I normally make the cumulative probabilities, I turn them to whole numbers. And how do you make them whole numbers? If you look at these, all of them are in 1 decimal point. So to turn them into whole numbers, I'm going to multiply them by what? By 10. So that when I multiply this by 10, this is going to be 1, this is going to be 3, this is going to be 6, this is going to be 9, and this is going to be what? 10. Then to get the random number ranges, I'll pick the starting point. If I have 1 here, the starting point, we start at 0, then we are going to end at 10. So if we had, we are going to see when you have 2 decimal places. So the starting point will be 0, that is the numbers 0 to 10. So we are going to start from 0 all the way to 10, all the way to 10. So when we start with 0, then we are going to pick the lower side of our value here. And the lower side means you less 1 from what we have here. So 1 minus 1 will be 0. That's why we only have a 0 here. Then you go to the next one. Now the first number here will be our 1, and then we take the lower side of 3, which is 2. Then 3 comes there. We take the lower side of 6, which is 5. Then we have 6 coming there. Then we take the lower side of 9, which is 8. Then we have that. Then we have our 9 coming here. We take the lower side of 10, which will still be 9, and that's why we only have one value here, which is 9. So basically that is how you get the random number ranges. That is when we have 1 decimal point, that is in tens. Okay, let's get the probabilities for the demand, number of fish sold to customers. So we are told 45 out of the 300 days the supply was 100. So what is the probability? It is x over 300 again. 45 out of 300, that will be 0.15. 60 out of 300, 0.20. You do the same. To get the cumulative probability again, this will be 0.15. Add this to get that. Add this to get that. Add that to get that, etc. Then cumulative probability. Now if you look at this, for us to be able to get the random number ranges, I'm going to make these whole numbers. How do I make them whole numbers? This time round, I'm going to multiply by what? By 100, because I have 2 decimal places. So this will be 15. I'm going to have here 35. I'm going to have 65. I'm going to have, this will be 90, and this will be 100. Then again, the starting point now here, we are in 2 decimal places. So I'm going to start at the point 0, 0. Then I take the lower side of 15, which is 15 minus 1, which is 14, right? Then 15 will start here in the next row. Then I take the lower side of 35, which is 34. Then 35 is going to start there. I take the lower side of 65, which is 64. Then 65 is going to start there. Then I take the lower side of 90, which is 89. Then again 90 is going to start there. I take the lower side of 100, which is 99. That's why we have 0, 0 to 14, where 14 is the lower side of 15. Then 15, 34, that 5, 64. As you can see, all the way to 90, 99. So as you can see, this chain is ensuring that there is a continuity in the values. We have 0 to 14, 14 to 15 to 34, 35, 35 to 64, 64, 65 to 89, 89, 90. So it is continuous. It's making it continuous like that. Having looked at that, it's time now to run the model. That is step 2. Run the model. So I'm going to use the random numbers that we have been given so that to run this particular model. So the random numbers, if I was to take you back to what we were given here, we are told to use these random numbers here. These are the random numbers we are supposed to use, and that is those are the numbers that I have copied here. Here, these are the random numbers. You can see that I have just taken them the way they are. Then the other thing you need to know, when you are allocating random numbers, we are only allocating random numbers to the variables. And how many variables do we have in this question? There are only 2. We have demand and we have supply. Those are 2 items that we are told they are varying over time. So we only have 2, and therefore we are going to allocate the random numbers to the 2 variables that we have. So we are doing, we are simulating for 8 days, as you can see. So I have written the 8 days up to there. Then we are simulating on 2 variables, that is the supply, and the other variable is demand. See that? So yes, we are random variables for we are simulating supply, we are simulating demand. So how do I allocate that? If you look at the random numbers will be allocated based on the random number ranges. And if you look at these ranges here, all of them are in 1 decimal point, are in 1 values, 0, 1, 2, 3, 5, 6, 8, 9. If you look at this one here, they're in 2 values, 0, 0, 14, 15, 34, 35. We are talking of 2 values. They're in tens, right? Then therefore, when you are allocating the numbers, you have again to look at that. So the first number, which is 5, will go to the first day. That is the supply for the first day, because supply, we have seen, it is in one numbers. Then the second 2 digits will go to the first day to the demand, because demand is in 2 digits. As in that. Then 4 will go to second day, 23 will go to there. We have 7 will go there, right? Then we have 39 will go there. So as you can see, that's what we are allocating. So 1 for supply, 2 for demand. 1 for supply, 2 for demand, right? So as you can see, again, I've taken all the blues, this is 7, 7, 4, 6, 3, 9. All of them, I have allocated them to supply. Then the red values here, the 2 of them, 2, 2, 2, 2, 2, 2, 2. I have allocated these to demand, as you can see there. Okay, that to demand. Then we have some values here, some numbers here that have not been used, and therefore, because we are done, we only have 2 variables, and we are simulating for 8 days, so we don't need these values. So we are just going to leave them at that point, because we have gotten enough values that we require or that we need. Now, after getting the random numbers, the next thing is to get the supply and the demand based on the random numbers. Let's start with the supply. So when the random number is 5, what would be the supply? You simply come and check here. when the random number is 5, where does 5 fall? 5 falls here. So therefore, the supply will be what? 300. So you come here and check. So we have the supply as 300. When the random number is 4, again, check on that. When it is 4, 4 again will fall on the same category. So it will be 300. There we go. Then when the random number is 7, you check again. So when it is 7, it is going to be here, 6 to 8. So 7 falls in here. So therefore, the number is 400. That will be 400. We have it there. So you check on that. We have 400 there. You've seen that. So basically, using the random numbers, you can be able to allocate the supply, right? Then we go to the other side, the side for demand. We go to the demand side. So to get the demand, you check the random number here is 73. So you check, where does 73 fall? The 73 is in here. So 73, that will be 400. You check, that will be 400. Then 23, check where 23 is. 23 is it is in here. 23 is here. So that will be what? 200. That will be 200, like that. 39 is somewhere here. So this one will be what? This is 300. So you proceed all the way to below values there, like that. So that is how you get the demand and the supply using the random numbers that we have obtained. The next thing that we need to get, remember, what we are trying to get is the profit. We are trying to get the profit for this particular business. Profit is gotten by taking the revenue minus the costs. Here we only have two sources of revenue. The first source is when a fish is sold when fresh. That is fresh fish sold. I'm calling it V. And a fresh fish is sold at 60 shillings. That's why I have V multiplied by 60. Another source of revenue is when a fish is sold that belongs to the previous day. Fish remains the previous day, it is sold the next day. And when they are sold the next day, they are sold at 20 shillings. So I'm calling these R. So R by 20, we have it here. So this is what is going to make up the revenue. The costs. What costs is Mr. Olo suffering at this given time? What costs are they incurring? The first cost is the buying price, and this is the cost for supplies. The supply that they get, they have to pay for it. So the supply, I'm calling it X multiplied by 40, because every fish is costing them 40 shillings. So this will be X multiplied by 40. That is the first supply. That is the first cost. Another cost is a shortage. We are told if they don't meet demand, there is a penalty of 20 shillings per fish that is not supplied. So we have these two making the cost. This will be the cost. I'm calling the shortage Q times 20. We have it there. Now, having said that, let's see how you get the various items. Let's start with day 1. Day 1, the supply is 300. This is the supply. Then the demand is 400. What does that mean? If the supply is 300 and these people are demanding 400, meaning the demand is more than the supply, right? And that means they are going to sell everything that they have. So the fresh fish, all of them will be sold. That's why we have fresh fish sold as 300. Then we don't have any previous day, we don't have any unsold, we don't have any donated, but we have a shortage because the demand is higher than the supply. Therefore, we're going to have a shortage of what? 100, right? We go to day 2. Day 2, the supply is 300. The demand is 200. What does it mean? It means the supply is more than the demand. So we are having excess. So we are going to sell whatever is being demanded, which is 200. Then the excess is going to remain as unsold. So we have unsold 200. We don't have anything for previous day, not donated, nothing for the shortage. We go to day 3. The supply is 400. Then the demand is 300, right? So as you can see, the supply is again high than the demand. So we are going to sell 300 that is demanded and remain, right? We are going to remain with 100. So we have 100 unsold. So we have 100 unsold here. The previous day we had 100 again that were not sold. So they were not sold here and they have not been sold the second day. And we were told that if fish is not sold the second day, what happens? They are donated. So the donation here is for fish belonging to the previous day that will not be sold because we have excess. We go to this day 4. The supply is 400. The demand is 300. As you can see, so we are going to sell the 300 and we have a balance of 100. We have 100 that is not sold. Then this for the previous day, again, will not have a market today. So we are going to donate them. The 100 here that had remained the previous day will be donated. We go to day 5. The supply is 300. The demand is 400. We have a higher demand than the supply. Means we are going to sell the 300 that we have and we have 100 that we are not going to satisfy. Right? We have 100 that we are not going to satisfy. So we have a shortage of 100, but that 100 can be met using fish from the previous day. So the fish that had remained here are going to be sold here. So we have sales for fish for the previous day, right? Then on day 6, the supply is 400, the demand is 400. So the demand is equal to the supply. So we are going to sell everything here and therefore nothing is going to remain. We have nothing remaining there. We go to 7th day. The supply is 300. The demand is 200. So we are going to supply the 200 that is being demanded and we are going to remain with 100 unsold, right? Then on 8th, we have 500 supply, 200 demand. So we are going to sell the 200 that is being demanded. Then we are going to remain with 300. Then the 100 for the previous day will not be sold because we still have more fish remaining. So we are going to donate this on this particular day. Now the next thing is to get the profit. And like I've said, to get the profit here, you need to take the revenue, which is V times 60 plus R times 20 minus X times 40, Q times 20. Let's start with day 1. Day 1, we look at that. V, which represents fresh fish sold. We have 300 fresh fish that were sold. And each fresh fish is selling at 60 shillings. Then we don't have any sales for fish belonging to the previous day. We have 0. So that's where we have. So this will be the income or the revenue for that particular case. The costs. Supply. We are getting a supply of 300 fish and each fish is costing us 40 shillings. Then we didn't meet the demand fully. So we have a shortage and every shortage is costing us 20 per fish. So we have that as the cost. So when you total up, we're going to remain with, we're going to have 4,000 as the profit. Like that. So that is how you get the profit for each day. Profit for each day. So I have summarized that in a table. So I have day 1 to day 8. Then I have the revenues. The revenues include fresh fish and previous day fish sold to give us a total there. The costs include a shortage and the cost of supply to give us a total there. Then when you take the totals, this total and this total here, it will give you the profit. That is the revenue minus the costs. That is K, which is the revenue, minus C, which is the cost. Give you that. You do the same. This will be 12 minus 12, which is 0. 18 minus 16, which is 2. So you calculate for each and every year like we have done for for each and every day like we have done for day 1, and you're able to get the profits for each and every day. Then the profit for the entire 8 days will be the total of these, which is you add all these values here, you add all of them to give you 16,000. Then that takes us to part 2 of the question, and part 2 of the question is saying, what are the average daily profits for Peter Olo? The average daily profit. To get the average, we normally take the total divided by the number of items. The number of items here, we have 8 days. So we are going to take the average of the 8 days. That is 16,000, which is the total profit, divided by the total number of days, which is 8. So 16 by 8, we are going to remain with what? 2,000. So on average, Peter Olo makes a profit of 2,000 shillings every day. 2,000 shillings every day. So that is how you apply Monte Carlo simulation model. I hope this tutorial was useful. In future, I'll look at more illustrations on how to apply Monte Carlo simulation. This was Virtual Wisdom Finance and Accounting Tutorials. I hope this content was useful, and if it was useful, kindly don't forget to subscribe. Kindly click on the subscription button there. Let your subscription count. The next time, we don't want to see the same number of subscribers. We want to see the number of subscribers increasing, because you will have subscribed to this channel so that you can keep following and appreciating the good work that I'm doing. Kindly subscribe to the channel. Also click on the bell icon so that you can be notified anytime I add new tutorials. These tutorials will be of benefit to you as a student, or in any other task that you're doing that you need to learn these models, you need to learn finance and accounting. Kindly subscribe and click on the bell icon, like the videos, share with your friends, and leave a comment. Appreciate the work that I'm doing. If you have a question, you can drop it here on the comment section, and I'm going to respond to it as soon as possible. Thank you for your time. Thank you once more. My name is Peter, and I was your host in Virtual Wisdom Finance and Accounting Tutorials. Bye.